right? So we'll see how many people were reading the opening crawl while I've been waiting. So I have a feeling that this is going to express the most controversial opinion of the entire night, that I think Jar Jar Binks gets too much grief, and the prequels weren't all that bad. So, like I said, the most controversial opinion of the night. So I got asked to talk about Star Wars. I would say, like a lot of the people in the room who are shouting out answers to the trivia questions, I remember waiting online at the movie theater down the road from my house when I was 5 years old to go see A New Hope. And I was 5, and I still remember seeing New Hope in the theater, and then going back a few years later to see The Empire Strikes Back, and then going back even a few years after that to go see Return of the Jedi. So I'm going to talk about Star Wars, but I'm going to shamelessly steal a presentation by a fellow Penn State faculty member by the name of Darren Williams. So Darren did his PhD here at Penn State in astronomy and astrophysics. I was an undergraduate, big fan of Star Wars and astronomy major, and I remember talking to Darren about his work on exoplanets. And many years later, I saw Darren give a talk very similar to the one I'm about to do, which is going to focus on the science of Star Wars, but in particular on the many worlds of Star Wars. So that's where that's what we're going to hear about now. So I want to thank Thomas for setting up a lot of what I'm going to say. And you know, I don't think Star Wars tries as hard as Star Trek does to get the science right, but I appreciate that Star Wars, like Star Trek, inspired a lot of good science, right? So many of us, I think, are here today doing astronomy because we saw these movies and it made us think, I wonder if that could really work. So I'm gonna show you an example of that in just a little bit. All right, so let's start out with, you know, this really iconic scene from the very first movie, Luke standing on Tatooine. Sorry, Michael. and looking up at the twin suns of Tatooine, right? So, you know, when this movie came out, the only planets we knew of were the planets in our solar system. And we very much wanted to find other planets out there, but we hadn't yet, right? It took another somewhere in the neighborhood of 15 years or so before we found the first planets. So when you're looking for planets, what you do is like a lot of areas of science, you go for the low-hanging fruit, right? So you look for planets where you think you're most likely to find them. This is not where we thought we were most likely going to find planets, right? The place we thought we were most likely going to find planets are around small yellow dwarf stars just like our own. So if we know that our sun has planets, well, that surely suggests that stars like our sun should have planets. Well, here's a world that's in some way must be orbiting a pair of twin suns. And so no one really thought, well, we're going to find planets around twin suns. But sure enough, not too many years later, we found a world orbiting around a pair of twin suns that in many ways actually seem to be very, very much like the worlds that George Lucas envisioned when he wrote A New Hope. So in fact, this is a press release from NASA announcing the discovery of Kepler 16b, a world orbiting a binary star system. And if I flip back and forth, it was no accident that those two suns shown from that planet are almost in exactly the same orientation with the same colors and roughly the same brightnesses. And it really does seem that this is a world that mimics in a lot of ways Tatooine. Well, we don't know that that particular planet is a desert or has moisture farms or droids on it, but it could. So many years later, we found a planet that seems very much like one of the ones from Star Wars. So what I want to talk about is, are there any other examples of this? So in the movies, are there planets that, since the movies have come out, we have found examples of? So here's another example, an exoplanet that's known as Gliese 1214b, and there's several other examples of planets like this. They're broadly called super Earths, so they're planets that are slightly more massive, slightly larger than Earth, but they're out there orbiting around their suns. As astronomers, when we find these planets, what we really want to do, and it's people like Thomas who do this work, and people like Jacob and Jonathan and some of the other folks here in the audience who are trying to characterize these worlds, and we think that some of them should be water worlds, right? So the properties of these planets suggest that, like our own, they might have water, and not just oceans or lakes or seas, but they might be like Camino from Attack of the Clones. So if anybody stomached that movie well enough and didn't mind going back and watching it, so this planet Camino was envisioned to be a complete water world, so completely covered in oceans from pole to pole down through the equator. So we have these examples of worlds like Tatooine orbiting around binary stars, super Earth water worlds like Camino in Attack of the Clones. So are there any other examples out there of planets like our own in our solar system or in other solar systems? So let me step back and let me talk for a little bit about the habitable zone, or the Goldilocks zone. So this is an idea that we use to try to organize for ourselves all the different planets that we've been discovering and what we think we might know about how those planets behave and how those planets work. So the idea here is you have different types of stars, from stars hotter than the sun, stars very much like the sun, down to stars that are cooler and smaller than the sun. And so there's this distance away from the sun, or distance away from that star, where the temperature could be just right on a planet orbiting that star for liquid water to be on its surface. And so we refer to that as the habitable zone. And so for a star like our sun, Venus is inside of the inner edge of the habitable zone. Earth is, depending on exactly how you define it, we think Earth is pretty much in the middle of the habitable zone. And then Mars is either near the outer edge or just outside of the outer edge of the habitable zone. So some of the worlds that you see up here on this image are planets that you might have heard about in the news. So like the TRAPPIST system that has a bunch of different planets that are found to be inside the habitable zone of this low mass small star. But one of the things that's not often talked about when astronomers talk about the habitable zone for stars is that the habitable zone evolves, right? So today we're 4.5 billion years into the sun and the Earth's history. And so over that 4.5 billion years, the sun's luminosity has changed and the sun's temperature has changed. And so as the sun's luminosity and temperature change, the position of this habitable zone changes a little bit. So we think that over time, as the Earth went from this molten, just forming planet to the planet that we have today that's full of life, like me and you and George Lucas, that the Earth has evolved, right? The Earth today is not like the Earth 4.5 billion years ago. And so one of the ideas that's proposed for how the Earth has evolved with the evolution of the habitable zone is there's this idea of what's called the snowball Earth, that if our Earth were covered, if our Earth at one point, we think that it was covered from pole to pole, from equator to equator, completely with ice. And so does that remind anybody of anything? Right? So we think that this may be, for habitable planets, this may be a required stage for planets to be habitable. There might have had to go through a snowball Earth phase. So we're searching for snowball exoplanets, and maybe that there was one called Snowball Hoth. So this, they never really say in the movie whether the entire planet was, so maybe this is the Antarctic of this particular planet. But it sure did seem to a lot of people who watched the movie that the idea was that this was a complete ice planet, very much like the theory for Snowball Earth. All right, so I think Thomas alluded to this a lot in his talk, and I want to make this point really explicit. So, A New Hope came out in 1977. The Empire Strikes Back came out in 1980. Return of the Jedi came out in 1983. So, astronomers like me in our 40s, we saw these movies when we were kids, and we were dreaming about becoming astronomers. And so, many years later, you're in college, you're in graduate school, and you're thinking about the universe, and absolutely your ideas about how the universe can work are influenced by these movies. So in my case, I can't point to something that absolutely 100% was influenced by having seen these movies. But like I said, I shamelessly ripped this talk off from my friend Darren Williams. So in 1997, this paper came out, Habitable Moons Around Extrasolar Giant Planets, by Williams, Casting, and Wade. And if you look online, this paper has something like 125 citations to it. It was published in the journal Nature. And so here's, from the beginning of this paper, here's one of the main scientific points of this paper in the literature. So what they argued in this paper, some of the first planets that we discovered around other stars like our own were giant planets like Jupiter, or even more massive than Jupiter. So many of us are looking for planets with life on it. We want to know, are those planets habitable? And when we started finding Jupiters, well, Jupiters don't seem very conducive to life as we know it, right? So you could probably come up with a way in which Jupiter could host life, but it's, if we're looking for life a lot like life on Earth, you're not going to find it on Jupiter. Well, this paper argues, well, let's look at the moons of Jupiter, like Europa and Ganymede and Callisto. So Europa, for example, in our own solar system, this icy moon of Jupiter, we think that Europa could potentially host life. And so this paper says, well, maybe there are rocky exomoons orbiting these giant planets in these other star systems. And so maybe that giant planet isn't habitable, but maybe the moon or a moon or multiple moons of that giant planet are habitable. So, where did this come from? Let's really test your Star Wars trivia. So this is a paper in the astronomical literature. It's in Nature, and I'll give you out his email address. He won't mind. I want you all to send an email to Darren Williams and ask him, why did he publish this paper about habitable moons around extrasolar giant planets? So who knows what that is? Here's another trivia question. This is the forest moon of Endor. Who lives on the forest moon of Endor? The Ewoks, right? So I want you to picture a proto-astronomer going to see Return of the Jedi when he was a youngster, somewhere in the range of like 12, 13 years old, and he sees this movie called Return of the Jedi, where these cute little creatures running around on a planet-sized moon that orbits around a gas giant planet called and this is one of the terrible things about the Star Wars universe, the forest moon of Endor, and the planet is called Endor, so they never really say whether the planet and moon are both called Endor. But so Darren saw this movie when he was a kid, goes to college, studies astronomy, goes to graduate school, and while Darren is in graduate school, some of these giant planets are being discovered, and he says to his advisors, I wonder if those giant planets can have moons, and I wonder if those moons could host life. And so they do the calculations, they write the paper, and they get it published that says, yes, we think that there can be habitable exomoons in the habitable zone of giant planets around other stars. And so the big takeaway that I want you to think about is, whether or not transporters are possible or real, whether or not lightsabers are possible or real, whether or not Death Stars are possible or real, moons of giant planets, sure enough, are real, could host life, and there are, at least some of us, the impetus for studying this was inspired by these fun movies. So that was all I wanted to say about the science of Star Wars. I decided to avoid talking about blowing up planets, talking about lightsabers. But if anybody has any questions, I will happily answer some questions about the science of Star Wars. Chewbacca's homeworld.
So could you pronounce
Tatooine.
It wasn't parsec.
Yeah. So the question is, unlike Star Trek, that worked really, really hard to use parsecs and astronomical units correctly, Star Wars did a terrible job with this, right? So Han Solo at some point when he's describing the Millennium Falcon says the famous Millennium Falcon that did the Kessel Run in 12 parsecs, which implies that the parsec is a unit of speed or time as opposed to distance. But those writers, those cagey writers, have come up like they did in Star Trek, have figured out a way to fix this gaffe in Star Wars. And so, like Thomas was saying, how the warp drive might be possible if you could warp space. So near black holes, you can effectively shorten lengths through gravitational effect. And so the writers claim that the Millennium Falcon got so close to a black hole that you can, depending on how close you're willing to get to the black hole, if you get far enough away, the Kessel Run would be effectively longer, and if you got closer, the Kessel Run would be shorter. So they've come up with a way to fix Han Solo's stupid use of the word parsec.
One of the things that's always bothered me about both series, from science perspective, is why all the spacecraft still fly like airplanes.
Yeah, that's a great point. So the question / comment was that in both series, right? So here you have spaceships that are navigating essentially very, very low density environments, which is very different than flying a plane in our high density atmosphere. And so why do they show these spaceships banking and flying the way you would fly in atmosphere? And right, so was it Babylon 5? Who's a Babylon 5 fan? I think it was Babylon 5, which was the only series that tried pretty hard to show spaceships moving realistically. I guess Serenity did that, I think it did too.
2001.
Yeah.
The new series expands.
One thing on that, and I don't know how much it is trying to fix something, is that in the last Star Wars movie, last for one day or two anyway, they show the X-Wings flying in an atmosphere. So
differently.
That at least would explain why those specific kind of a starship is made that way. Not everything else. Why?
Yeah, so Boris made a good point, right? So again, as people have picked apart these movies, and I will point out that my wife hates going to see science fiction movies with me because she claims that scientists are so obnoxious at these movies when we pick apart the science. So again, as we picked apart all these science fiction movies, so Boris points out that in the more recent movies, they show the X-Wings flying in space and then also flying in atmosphere. So you have to design the ship so it's capable of doing both and should maneuver similarly, right? But retconning, good stuff. And was there a question over here that I ignored? All right, so who wants to know the answers to the trivia questions?
Yeah.
Okay, all right. I'll give it to Michael to do that.
It's like below you.